Okay, so we're going to have a video lesson today, and we're going to continue our discussion on finding derivatives. So first, if you haven't already checked your homework due for today, please check it. And that was the 23 through 33 all on page 156, I believe. But we need to talk a little bit more about find the derivative. And I want you to pull out your notes from Wednesday morning, and I'm going to use those notes to help to finish this discussion. So turn to the third page in your notes, and we're going to talk about the power rule. So remember, you've got the power rule when the coefficient is 1. You've got another version of the power rule when there's a number in front of the coefficient. And you just multiply the coefficient times the exponent and subtract 1 from the exponent. And then a derivative of a constant is 0. Those are the 3 rules we discussed on Wednesday, and then we worked these examples. All right, so we're going to use that information to help us with some application problems. Turn to the last page. All right, for the function 8x minus x squared, find the slope of the tangent lines at x equals 2, 4, and 5. Find the equation of the tangent lines at x equals 2, 4, and 5. Sketch the curve and the 3 tangent lines. So here we go. As you remember, a derivative is the same as the slope of the tangent line. So if I want the slope, I'm going to find the derivative of this function. And remember, if it's in terms of x, it's at any value of x. So this is the form you want your derivative in, because it will apply to any value of x that you plug in. The derivative of this function is 8 minus 2x. So let's find the slope at x equals 2. That's f prime of 2. Let's find the slope at x equals 4, and that's the derivative at 4. And then slope at x equals 5, and that's the derivative at 5. All right, now I've got to find the equation of the tangent lines at each of these x values. Well, you need 2 things to find the equation of the line. The first thing you need is a point. The second thing you need is a slope, and you plug it all into point-slope form, which is y minus y1 equals m times x minus x1. And you'll be plugging in numbers, values for y1, m, and x1. Okay, I think I'm going to run out of room, so I'm going to get another piece of paper. All right, so we have the slopes at each of those points, and we've got an x value, so we have to find the y value at each point. And we look at finding the y value first at x equals 2. So f2 is 8 times 2 minus 2 squared is 12. So my point is 2, 12. Let's write the equation of the line. Remember, we're using y minus y1, point slope form, times x minus x1. So y minus 12 equals, remember the slope at 2 was 4. 4 times x minus 2. And we're finished. That's the equation of the line. If you like, you can simplify it more, but you can leave it in point slope form. All right, let's find the value of the y coordinate at 4. So the tangent line, the point is 416. So the tangent line is y minus 16 equals 0 times x minus 4. Well, 0 times anything is 0. So y minus 16 equals 0, y equals 16. That makes sense because if the slope is 0, the line has to be horizontal. Let's find the value at 5. So 8 times 5, 40 minus 25 is 15. And y minus 15 equals, the slope at 5, remember, was negative 2. X minus 5, and we can just leave it there. All right, it says sketch the curve and the 3 tangent lines. Well, let's remember what shape f of x equals 8x minus x squared is. Because the square is a parabola, and it's going to turn down. So we know it's in the first quadrant. Because I'm going to go ahead and explore my x-intercepts. So I'm going to set the f of x equal to 0. I'm going to factor out the x. And my x-intercept is 0 and at 8. So like we said, we know it's a parabola that turns down. I know I have a horizontal tangent at 416. So that's going to be my tallest point. And it's going to turn down. That's the only place a horizontal tangent can exist, is at its max or its minimum. All right, so at 212, I've got a slope of 4. That's pretty steep. So there's a tangent line at 4, a tangent line at, that's at 2. The tangent line at 4 has a slope of 0, and the tangent line at 5 has a slope of negative 2. So I know my curve is starting to decrease because it has a negative slope. Okay, go back to your note sheet. And another application problem is talking about how different names of a derivative. And when you're talking about position, the rate of change, which means derivative, has a special name. The rate of change, or the derivative position, is called velocity. So position is usually given an S notation. So S of t is position. The derivative of S is called velocity. All right, so let's look at this example. Suppose the sailboat observed over a period of 5 minutes. The distance in meters traveled at time t minutes is, so there's my distance, my position function. I want to find how fast the boat is moving at the starting point. Well, starting point is when time is 0. How fast the boat is moving at the end of 3 minutes. And write a sentence describing the position changing at t equals 3. Okay, so if I want to know how fast, that's the velocity. So I'm going to go take my position function and I'm going to take the derivative and find the value of the derivative at the starting time, which would be 0. So my velocity is 60, don't forget the unit of measure, meters per minute at t equals 0. How fast is the boat moving at the end of 3 minutes? That means what's the instantaneous rate of change at the 3rd minute? So S prime of 3, 3 times 3 squared, 27 plus 60. So the rate of change, the velocity at t equals 3 is 87 meters per minute. All right, so let's write a sentence describing what this means. The boat is increasing its velocity at 87 meters per minute at 3 minutes. So my velocity at that time is increasing because I'm going to be going 87 meters per minute faster by the next time frame. Okay, now you may start your homework. Check your course page. The numbers for homework are listed on the course page, and I will see you Tuesday, and your quiz is going to be Wednesday.